Okay, this is 7.RP.3, 7th grade, Ratios and Proportional Relationships, Standard 3, Video 1, and we're going to be talking about percents, decimals, fractions, how they relate to each other, and more importantly, we're going to really be getting into the standard that says use proportional relationships to solve multi-step ratio and percent problems. And I believe we've talked a little bit about interest and tax markups, markdowns, all the different types of percentages that are taken off or added on to given values. Few terms to know. I'd like you to jot these down in your journals and define them. Okay, so talking a little bit about percent, I think it's important to note that the word percent means per hundred. And if we're talking about ratios, which we've done a lot of, a ratio is a comparison of two numbers. So if we're dealing with this first example that says 50%, that percent sign means we're going to take that number and compare it to 100. So we have a fraction called 50 per 100. And if we were to reduce that fraction, which we always want to do here when we're talking about percentages, we want to reduce it down to its simplest form. And in this case, we get 1/2. And then we're going to also be talking about the relationship again about the fractions to decimals. And if you recall the way we got a decimal from a fraction, we went with a division, we take the numerator and we divide it by the denominator, and we go through the process of division. And we come up with 5/10. So if you read this decimal right here, I want you to also make a note that this is the 5 in the tenths position. So if we were to read it as a fraction, it says 5/10, and again that reduces down to our friend called 1/2. So we see a lot of relationships here between percentages, fractions, and decimals. Looking at the second one, I have 37%. So as a fraction, we have 37 per 100. And we're looking to see if we should reduce it to simplest form. And this one already is in simplest form. So I'm just going to relate this to the decimal for now. And we read this as the 10th position, and then the 7 is in the 100ths position. So we read that as 37/100ths, or 37%. Also in the standard, we're going to be talking about percentages that are larger than 100%. And in the bottom problem, we have 110%, which still means we take the 100 and we set up a ratio. So it says 110 per 100. If we were to reduce that fraction, which we know it can be reduced, I can find a number that goes into both of them, but in this case, since I have zeros on the end, I know that I can cancel out a 0 in the top and the bottom, and that leaves me with 11/10. Simplifying that even further, we know that it's improper. An improper fraction means we take the top number, we divide it by the bottom, and we end up with 10 going into 11 one time, with 1 left over the denominator. We have 1 1/10. And if we were just to read that as a decimal, we know that the 1 is in the 10th position, so we have 1 whole and 1/10 left over. And if you don't know how to read that yet, you're not familiar with getting this 1 in the 10th position, again, you can take that idea from the top. We could take the 1/10 and divide it using our log division. And you would end up with 0.1 in this case. Okay, your turn. What I'd like you to do, we're going to roll through a bunch of different types of problems. The first one, it says write the percent as a fraction. So it's really important that you read the directions on every single problem or situation. And this one says, I'm giving you a percent and write it as a fraction. So we know now that 8% is 8 per 100. And now we make sure that it's in simplest form. So think of a number, if there is one, that goes into both of those. Good. They're both divisible by 4. We know that 4 would go into both of them. You might be thinking of 2 because they're both even, but try to find the largest number. It'll save you a lot of time. So 4 goes into 8 2 times, and 4 goes into 100 25 times. So that is the fraction in simplest form. Okay, the next one says 14%, which is 14 per 100. And again, thinking of a number, they're both even. I know that 2 works. Let's go with 2. So 2 goes into 14 7 times, and 2 goes into 150. And then make sure that 7 over 50 is reduced. And we know that it is. The only number that goes into both of them would be a 1, and we are simplified. All right, the next set deals with writing fractions now as a decimal. So we're going to be looking at the relationship in which these fractions have a decimal value. And again, we're working all the way to percentages. The standard really wants us to work this into a percentage form. And again, this is a review of taking these fractions and decimals and relating them to each other. So very quickly, maybe some of you have decided that we are one step away from getting this decimal. 3/10 can be read as 3 in the tenths position. Again, if you're not there yet and you can't see that, we can always take this as a long division. So 3 divided by 10, your numerator divided by your denominator. And 3 goes into, or sorry, 10 goes into 3 0 times. 0 times 10 is 0. We subtract. And 10 cannot go into 3, but I can add a decimal point, bring it up, add a 0, and bring it down. We've worked a lot with that. So if the 0 comes down, now 10 goes into 30 3 times. 3 times 10 is 30, and we now have no remainder. So just like we said before, we know that 3/10 is known as 0.3. 3/10. All right, the next problem over, 13/25 cannot be quickly written as a decimal like we did in the first one. So we are going to have to use our long division skills. So we're going to take the numerator and divide it by the denominator. And 25 cannot go into 13, so it goes in 0 times. We're left with 13, and we knew that. So we add a decimal point, bring it up, add a 0, bring it down, and think about how many times 25 goes into 130. Well, we know that 25 goes into 100 4 times, and then 25 can go into 30 one additional time. So what does that give us? So that would be 4 plus the 1 time is 5 times. And I think there's going to be a remainder here. So 5 multiplied by 25 is 125. We subtract. We're left with 5 remainder. So 25 cannot go into 5. We add a 0, bring it down, and let's see here. 25 goes into 50 2 times, and we have no more work to do. We ran out. We have no remainder. So the decimal form is 52 100ths. Now, I do have a way of solving this much quicker. That will be coming up in another video where we start using proportions, proportional relationships based on the per hundred idea. We're going to save that because again, I thought this would be a good video to review how to work fractions and decimals. All right, now we're going to put all of this together. We are going from a fraction to a percentage. Again, later on, I'm going to teach you a very fast way of getting from 7/20ths using a proportion, getting the percent out of that. But I want to go just a review of all of the long division, maybe the decimal discussion, so that later on when we get into these ideas of tax and tip, you'll have a foundation for that. So how would we do this? We have a fraction, that means 7 out of 20, or 7 per 20. Let's get a decimal first. So numerator divided by denominator. That's 0 times. And add a decimal, bring it up. Add a 0, bring it down. So 20 goes into 70 only 3 times. Subtract, we have 10 left over. Add a 0, bring it down. And 20 goes into 100 5 times. And that gets us a remainder of 0. So now we have 35 hundredths as a decimal, but the directions want us to get it as a percent. So how do we do that? Good, you remember that if this is read as 35 hundredths as a fraction, we know that it is 35 per 100. And how do we read that? Well, per 100 means percent. So we have 7/20ths equaling 35%. All right. One special note, I want you to note that if we ever did a problem that came up with a division answer of something like, how about 0.2, and we didn't have any number after the 2. So we read that as 2/10. Well, what can you always add to the end of a number, and it won't really, it'll change its look, but it won't change its value when we're talking about decimals. Do you remember what we could add here? Okay, we could put a 0 at the end. And how would you read this one? We would read it as 21 hundredths, or 20%. Okay, so I don't want you to get mixed up. I know I kind of sidetracked there, but you are going to come across some situations where you're not going to get this perfect 2-digit number after the decimal, so you have to do a little thinking sometimes. All right, I believe this is the last part. It's taking percentages of numbers. So if you put it to an example, you might say, all right, so I'm having a party at school, and there are 75 cupcakes that can be distributed, and I want 20% of them saved. Maybe the teachers are coming a little later, and we don't want to eat all of the cupcakes, so we want to leave about 20% of them for those nice teachers that you have. So we need to figure out how many we're going to have to save. Again, there are many different ways that we can figure this out. I'm going to do it as a ratio. We're going to set up a ratio, 2 ratios that will ultimately become a proportion. So 20% is 20 per 100. And of in math, this word of means multiply. And then we know that 75 can be written as a fraction that still means 75. we put that over 1. So we have 75 over 1 multiplied by 20/100ths. Now, I can do my cross canceling right now and try to figure out what goes into 75 and 100. But before I do that, I don't like those big numbers. What can 20/100ths be reduced to before I start multiplying it by 75? Hey, Seuss. Sorry, we paused there. So we have 21/100ths, and I would like to reduce that to a simpler form. And do we know what that's going to be? Good. 20 goes into 21 time, and 20 goes into 105 times. So now we bring down our 75 over 1. And uh, what do you think we can do here? Can we take a 5 and divide a 5 into both 75 and 5 so we can kind of simplify this a little easier for us? Okay. I'd like you to figure out what or how many times 5 goes into 75. Anyone know? Okay, so if you don't, again, it takes us to our long division. We know that they both end in 5s, so you could take 75 divided by 5 goes 1 time. Oops, sorry. We're left, oh, I don't want to do that to you since we're showing all of our work here. So we have 5, and then we would subtract. So we have 7 minus 5 is 2. Bring down the 5. 5 goes into 25 5 times. So we can simplify this. 5 goes into 5 1 time, and 5 goes into 75 15 times. And now we can multiply straight across. So we have 1 multiplied by 15 is 15, and 1 multiplied by 1 is 1, and that would simplify to 15. So when it comes to 75 cupcakes at the school function, and we want to save 20% of them for our teachers, we would leave 15 for them to eat. Okay, next scenario, we have 75% of 52. You can put, I'd like you to actually write down a real world example of what you might have when you're taking 75% of 52. And then I'd like you to bring that to class and we'll see what kind of scenarios you came up with. But if we're doing it mathematically, we have 75%. We know that 75% means 75 per 100, so we'll take that percent sign out, we'll make it a fraction per 100, and of, we know, of means multiply 52, and 52 will go over 1. All right, now let's do some canceling here again. We have 75 over 100. We know that we can reduce that. So 25 goes into 75 3 times, and 25 goes into 100 4 times. And I think that'll make our life just a little bit easier here. All right, 4 and 52. You know that they're both even, so you might be thinking, let's divide both of those by 2. And 4 actually goes into them. So I'm going to do that just to save some time. 4 goes into 4 1 time, and 4 goes into 32. All right, sorry for that pause again. We had a little announcement there. 4 goes into 4 1 time, and 4 goes into 52 13 times. And let's see, we're going to end up with 13 multiplied by 3, which is 39 over 1. So we are going to have 39. So 39 is 75% of 52. So if you want to write it as a fraction, I would say, so 39 out of 52 is equal to 75%. Okay, in your journals, I'd like you to define the given terms, write a few sentences on what you learned from the video, bring that scenario, that real world story that represents the last problem that we did. We'll talk about those. And realize that this was really just a review of fractions and decimals, and we're kind of leading into this world of percentages. All right, have a good day.